So I've also put the full lyrics online, so if you want to look them up later and try singing it, just go there. I hope you forgive me using this sheet of notes, but this is to help make sure that this presentation is going to be less than 20 minutes. Because when I practiced this, it just went on and on and on. Because I just got done teaching a one semester course.
Did it?
Any better?
It's on.
Okay. I'll just put it closer like that.
Yes.
I just got done teaching a one semester course in Astro 1. And if I don't use the notes to keep me to 2 to 3 interesting points per slide, then I'm just going to say like 30 or 40 or 50 per slide, and this presentation will last 15 weeks. So, here we go. Opaque ball of hot dense gas, million times our planet's mass.
The sound was on
Looking small
before,
because you're far,
and it went
I
off.
know exactly what you are. If our sun were a grapefruit in New York City, Earth would be a poppy seed, half a tennis court away. That's about 12 meters. The next closest grapefruit, the next star, Proxima Centauri, would be in Salt Lake City, over 3,000 kilometers away.
Mommy, your voice sounds quiet there.
Yeah, we're losing your speakers for some reason.
All right, I'll let the tech gurus work on that while I just charge ahead. Constellations are at best just a cosmic Rorschach test. Random patterns spread 3D. Viewpoint dictates what we see. Stars in a constellation are typically nowhere near one another in space. It's just our perspective that makes them appear close together in the sky. And the patterns are completely arbitrary. Atmospheric turbulence causes rays of light to bend. Blurry light gives views subpar, causing twinkling little star. I know that's a near rhyme, not a perfect rhyme, but I had to sacrifice a little of the rhyme to get the science right.
Yeah.
Stars themselves don't intrinsically twinkle. The atmosphere makes stars only appear to flicker and jump around, or twinkle. If Earth's atmosphere were perfectly still, or absent, then the stars would appear as perfectly tiny dots. No twinkling. We see you as if in the past, light's not infinitely fast. Look back time delays our view, showing us a younger you.
Mommy?
We see the sun as it was just over 8 minutes ago. The nearest stars, we see them as they were a few tens of years ago. Distant stars, thousands of years ago. And other galaxies, millions or even billions of years ago. Because of the finite speed of light, introducing a lag time. Fusing atoms in your core, hydrogen, helium, carbon, and more. With such power you shine far, twinkle, twinkle, little star. When the universe first formed, only the first few simplest elements were present, primarily hydrogen and helium. All of the other elements came from nuclear fusion inside of stars, which produces energy, makes the stars shine. Without stars, the universe would not contain any of the other elements, or any of the raw ingredients for planets, solid matter, or life. Credit to Jason Wright for this verse. Classed by their spectroscopy, types like OBAFG, bright when close and faint when far, I know exactly what you are. The hottest stars give most of their light in the blue part of the spectrum. Intermediate stars give off a lot of light at all the colors of the visible spectrum, and the coolest stars tend to give off more light at the redder end of the spectrum. Smallest ones burn cool and slow, still too hot to visit though. Red stars dominate by far, twinkle, twinkle, little star. Red, so-called cool stars, and I'm obnoxiously using scare quotes because they're cool by star standards, but not by terrestrial standards. Still several thousand degrees. Red stars are the most common type of stars in the universe, outnumbering big hot stars by 30 to 1. Largest ones are hot and blue, supernova when they're through, then black hole or neutron star. I know exactly what you are. When a high mass star runs out of fuel, its core collapses and it explodes in a catastrophic supernova. The tiny core left behind is a neutron star. If the neutron star has enough mass to crush itself under its own gravity, it will continue collapsing to form a black hole. Now we have one additional verse about each of these three objects because there's so much more to say. Supernova, black hole, and neutron star. Big stars fuse a heavy core up to iron, then no more. Then the core collapses fast, type 2 supernova blast. When the core collapses suddenly upon reaching the conditions for iron fusion, the outer layers fall on top of it and are explosively ejected off the rebounding core as a supernova explosion, but the core remains behind. Neutron stars spin really fast when their beams of light sweep past. Then we call you a pulsar, twinkle very dizzy star. My daughter wrote that line. Wave hi, Georgia. The core is now called a neutron star, a rapidly spinning, tiny, tiny star. Sometimes these can be seen as pulsars. Imagine the beams of light from a lighthouse sweeping around as the light spins. If you are lined up with one or both of the beams, then you see a flash or a pulse of light once or twice per rotation. Gravity holds on too tight. Nothing gets out, mass or light. Black holes are the most bizarre remnants of a twinkling star. If the collapsing core has more than about 3 solar masses worth of mass, then it continues to collapse, not stopping at the neutron star stage. It continues collapsing to form a black hole. All the mass of the black hole is contained at the center in an infinitesimally small volume called a singularity. Inside the event horizon, typically just a few miles across for a stellar mass black hole, the escape speed exceeds the speed of light, which is why nothing can escape, not even light. So that's the end of the story for the highest mass stars, but lower mass stars behave differently. Our sun's average as stars go formed 5 billion years ago. Halfway through its life so far, twinkle mid-sized yellow star. Our sun is intermediate between the smallest, coolest red stars and the largest, hottest blue stars. Its true color is actually whitish. This picture is taken with a special filter to highlight the surface features like prominences, granulation, and sunspots. And the filter makes it look yellow. Our atmosphere can also make our sun's color look yellow, even though it's technically white. All right, we're halfway there. Sunspots look dark, but they're bright, slightly cooler, so less light. Temporary surface scar. I know exactly what you are. The high contrast filter makes the sunspots look much darker than they actually are. Sunspots can be many thousands of kilometers across, larger than the planet Earth. Superimposed here just for size reference. Swelling up before it's dead, cooling off and growing red. Then its end is not so far. Twinkle, twinkle, giant star. When small stars run out of fuel, their cores shrink and their outer layers swell to 100 times the star's previous size. That's why they're called red giants. Our sun will do this in about 5 billion years. The orbits of Mercury and Venus, and possibly Earth, will be enveloped in the red giant's outer layers. And eventually, outer layers float away, planetary nebulae. Wispy gases gossamer, I know exactly what you were. Red giants' outer layers get spread out so far, the star's gravity can no longer hold on to them. They drift off in a gentle cosmic burp. Our sun will also do this. White dwarf is the core you get. Matter is degenerate. When small stars say au revoir, twinkle very little star. A white dwarf is very tiny, just a few thousand miles across. Not as tiny as a neutron star, but still tiny by cosmic standards. And it still has half the mass of the star in it. Due to the strong gravity, the material is squeezed to very high density, like squeezing an entire Toyota Corolla into the size of a sugar cube. That's how dense they are. Now that's the end of the line for low mass stars. Well, if they're left alone to fade into oblivion, which is what happens most of the time. But if they're not left alone, you can get some pretty spectacular fireworks. And not fire like chemical burning fire, but more like fusion fire. White dwarfs with a nearby mate can endure a different fate. If the pair does mass transfer, nova flare-ups can recur. If a white dwarf is in a very close binary system, and if its companion evolves after it, swelling up as a red giant and spilling some of its mass over onto the white dwarf, the newly added hydrogen on the hot surface of the white dwarf can flare up in a brief burst of surface fusion called a nova. So this shows the white dwarf at the middle there. The red giant swelled up and encroached on the gravity of the white dwarf, and the material started spiraling down and then eventually settles on the surface of the white dwarf, and when there's enough of it, it can flare up. That can't go on forever. Sometimes it stops on its own, sometimes not. If white dwarfs gain too much gas, 1.4 suns worth of mass, supernovae then forebode. Now I know how you explode. If enough mass spills over, the entire white dwarf core, which is predominantly carbon, will simultaneously and suddenly achieve conditions for fusion, and the whole thing will explode at once in a catastrophic supernova, destroying the white dwarf entirely and leaving nothing behind. A thermonuclear bomb. This is my son's favorite verse. Want to wave your hand, August? You can sing along if you want. Interstellar medium, recycled ad nauseum, gas and dust are spread afar. I know exactly what you are. It's also my favorite verse because I used to study the interstellar medium. This material forms the galactic ecosystem in which stars live. It provides the raw material for their formation and is where some of their material returns after a star dies. There it is ready for the next generation of stars to form. And now we'll complete the loop from death, rebirth. Forming from collapsing clouds, cold and dusty gas and shrouds, spinning, heating protostar, soon to be a newborn star. Regions of the interstellar medium contract under their own self-gravity. When a gas compresses, it heats up, much like pumping air quickly into a bicycle tire. When it gets hot enough for nuclear fusion to ignite, a star is born. Often forming multiply, clusters bound by gravity, open type or globular, now I know how you occur. Globular clusters have fewer than about 1,000 stars. Open clusters have fewer than about 1,000 stars. A couple of astronomers almost had heart attacks when I said that. The gravity holding the group together is weak, so they tend to disperse over time. Globular clusters are the big ones. They have 100,000 stars or more maybe. The grouping is tightly bound, so a globular cluster persists indefinitely. This is an open cluster, a loosely bound group of fewer stars, and this is a globular cluster, a more tightly bound group of many more stars. But in both cases, it's a bunch of stars that were born together. Two stars make a binary, or a triple if there's three. Some are solo just like ours, twinkle twinkle little stars. Stars tend to form in batches, clusters like I just showed you some pictures of. Even within those clusters though, the individual stars tend to have smaller groupings, 2 orbiting as a pair, or 3, or 4, etc. Solitary stars like our sun are in the relative minority. Our sun may have formed as part of a cluster, maybe an open cluster that later dispersed, but our sun is solo now. Only 2 more verses, you're almost there. 250 billion stars all stay bound within the Milky Way. Dusty spiral with a bar, twinkle galaxy of stars. Dusty spiral with a bar, that's Jason's line. I want to give him credit. A galaxy is comprised of many star clusters and solar stars like our sun and the intervening interstellar medium, all orbiting one another due to their cumulative mutual gravity. The Milky Way is one galaxy, but there are hundreds of billions such galaxies in the observable universe, each having hundreds of billions of stars of their own. And also planets. Stars have planets orbiting, rocky or gaseous moons and rings. Earth's unique with life so far. Twinkle, twinkle, little star. Planet searches have revealed thousands of planets around just the nearest stars in our own galaxy, with more being discovered all the time. Planets are plentiful in the universe, it turns out. A wide variety of sizes and compositions. Many, if not most, stars seem to have planets. But of all the thousands of planets discovered to date, nowhere else in the universe besides Earth shows any evidence for life. Yet. You should keep looking. So, if you want to take home a copy of a dozen or so of these verses, I've got them on the coloring page here, or you can look them up at that link. And we should also mention, not a major motion picture, but 12 of these verses have been published as a picture book now, and I just happened to bring a couple extra copies in case people want to buy some for the holiday shopping season, but there are only 12 verses in here, so if you want to see all 24 that you just heard, you've got to go on that link that was on the screen before. I also have a couple of other children's books that came out earlier this past summer. ABCs of Space, 26 astronomical terms with definitions suitable for all ages, from asteroid to zenith. And then Astrophysics for Babies, which tells about how the atoms inside your body were made in stars. So please feel free to take any of my handouts. I've got bookmarks, I've got more ABCs of Space and Astronomy Challenge word search puzzles that people are welcome to take. And if you're really up for it, the Space Challenge anagram puzzle. Thank you, everybody.
Any questions?
Since you say you had interest in interstellar space, so good day or good week before you now officially in interstellar space, right?
The question was about the Voyager spacecraft now officially in interstellar space. The farthest human-made objects from Earth are the Voyager spacecrafts. So, yep, they've gone well beyond the range of influence of just our sun and now are officially in interstellar space.
Today, Cindy can talk.
I got one question. So you mentioned how the sun was the sun is, we think it's a yellow star, but the truth is it's actually more of a white star. Are there any stars that are truly yellow? Or are they all just kind of white stars masquerading?
I guess I don't have to repeat the question because you had the microphone. Stars that are a little cooler than our sun will look more yellowish. And stars that are a little cooler than that will look more orangish, and cooler than that will look more reddish. Like the low mass stars I described as red. Well, they're not all just red. They can be orangish or yellowish. And then an intermediate star like our sun is more white.
What was your favorite part about writing these books?
The question was, what was my favorite part about writing these books? So I started with the Twinkle Twinkle project and never intending for it to be a book, but I had a newborn baby 8 years ago. That was Georgia. Hey, Georgia. And I don't know if any of you have parents in the room, but the things you do to try to keep your brain from going insane when you're sleep deprived and trying to get a baby to go to sleep. And since I was an astronomer, I just started working on these lyrics in my head, and it was just a song that I sang to her for the first couple of years. And then I started writing it down. I got so many that I couldn't remember them all at once. And so eventually somebody encouraged me to try to make it into a book, and I got really lucky and it worked. But my favorite part was singing them to my daughter.
And we thought, you guys,
Yeah, just you're like Nero deGrasse Tyson said about Twinkle Twinkle Little Star. He said that most when people wish upon that star, usually it doesn't come true because the first star they see in that is usually Venus.
So the question was about a lot of people wish on a star or twinkle twinkle little star, the first star I see tonight. The reason that doesn't work maybe is because the first star you see at night is often Venus. Venus being the brightest object in the night sky after sun and moon. Well, sun is daytime sky, but moon can be up in the day or the night. And then the third brightest object visible from Earth in the sky is Venus. And it's often mistaken for a star, but it's just visible first because it's brighter.
I used to be in school.
And also, some of the stars that you might wish on, if they're more than a couple thousands of light years away, maybe they're not even there anymore. Because of look back time, you're just seeing a ghost image from the past.